everyone. I'm Sangeetha, working as Assistant Professor at Dr. S.N.S. Rajalakshmi College of Arts and Science in the Department of Graphics and Creative Design. Here I'm going to explain about real-time noise suppression on edge devices using a practical AI-based approach. Here the challenges is noise is generally assumed to be random and can cover a wide range on the frequency spectrum. If the noise does not fall in the same range as a speech, a well defined digital filter would be sufficient to reduce the background sound. However, it is different when the noise and speech can overlap the frequency. Here, the main challenge of the noise suppression technique is to make it work well consistently for all kind of noise. To address both stationary and non-stationary noise, designer must look beyond the traditional method. Here the solution is, we can see, enter Ignitorium, a product engineering design company based in India, which has implemented in a small memory footprint a deep learning based real time noise suppression software that can run on low cost microcontrollers. So, drawing on our strength in multimedia, DSP, and the many years we spent on video AI, it was natural for us to see what we can do with AI in the field of audio analytics. We understand semiconductors and ecosystem very well. This opened up an interesting opportunity to implement real-time audio analysis on embedded devices, paving the very way of the first engagement with lead customers. Here, Ignitorium real-time noise suppression algorithm is one such approach, where a linear regression method is used to denoise noisy speech input in the real time. Here we have some key features. First one is deep learning, and then we can only use the small memory footprint, and then we can use low latency, and then we have to use sampling rates optimization for high performance. For example, if you are taking some voice, it will be converted to the segmentation and then frequency domain analysis, so it will be moved to the frame synthesis directly. Otherwise it will be go to the feature extraction, customer neural networks, and then it will be sent to the frame synthesis. And then next one is, here we have some processing approach. This input floating point sampling are passed through a segment, store the segment, that is a segment and frequency domain analysis process. This includes a high pass filter to avoid low frequency component. The filtered output is then fed to features extractions. Here the feature extractions are the noise suppressions. Again is computed based on 22 bands of the bark sound scale. So here we can use the neural networks. The extracted features are fed to a recurrent neural networks, and then research and experimentation at the Ignitorium labs have shown gated recurrent unit to be performing slightly better than same task and require fewer resources. RNN layers are important here because they make it possible to model time sequences instead of just considering input and output frames independently. Here we have some noise profiles. The standard pre-trained model supports so urban home and missionary office. The solution is not limited to the profits mentioned above. The model can also be customized to a specific noise, or a new noise profile can also be added. The NN based models are very good at what they are trained for. Hence, the quality of the training data is critical in achieving results. The suppression algorithm can be used for stationary as well as the non-stationary noises. The correction between the clean audio frequency component and noise frequency noise frequency components decreases, the performance increases. So the main challenges for edge level computations are the available processing power and memory. Ignitorium has engineered the right balance by figuring out a suitable NN architecture that can be implemented and on controller devices. Most of these devices have RAM under 30 KB. Implemented a solution to suit the limited processing power and memory in these devices. Thank you.